Okay, good morning, grade 9s. Just going to take a minute here to do a few of the questions with you. I know there's an answer key at the back, but sometimes it's just a little nicer if we can walk through a question. So I have my ruler handy and also my calculator. Sometimes that's just helpful. So I asked you to do 1 to 7 and 12. I kind of walked through 4 and 5 with you yesterday as an example. So we're going to work on 6 and 7 and 12. So question number 6 says, there's a photo of a surfboard that has dimensions of 17.5 by 12.5 centimeters, and we're going to make enlargements. That means they're going to get bigger, and that is why all the scale factors listed here are greater than 1. If they were less than 1, we'd be making a reduction, which is going to be tomorrow's lesson. Okay, so if we were to increase these by a scale factor of 12, what you would do, and here's my picture, is you would multiply each of these dimensions by 12. Okay, it's as simple as that. So for 6a, you should have just taken your calculator, and you should have had 17.5 times 12, and your new dimension is going to be 210 centimeters by, and then you take your 12.5 and you multiply that by 12 as well, and you should have got 150 centimeters. So if you check at the back of the book, you should have 210 by 150. Okay, so for letter B, we're just going to multiply both pieces by 20. That makes sense. So question C is where I'm a little concerned because I don't know how well I explained that yesterday. If we were to take our scale factor of 7.5, now you can work with that, but in my mind, what I like to do is I like to turn that into a decimal. I just feel more confident working with that. So 7 divided by 2, and you should got that the scale factor is 3.5. Okay, so now we're just going to take our original dimension 17.5 by 12.5, and we're going to multiply each of those by 3.5 because that was the new scale factor. So 3.5 times 17.5, I'm not going to do that in my head, 61 and 25 100ths of a centimeter. Remember, dimensions have a unit, but scale factor does not have a unit. And 12.5 times 3.5, and you should have got 43 and 75 100ths of a centimeter. So that's how you do that one. So for the scale factor here for D, I would have taken 17/4 and I would divide 17 by 4, and you're going to get that that scale factor is 4 and 25 100ths, and then you're just going to multiply that. So I hope that made sense. Okay, question number 7. Question number 7, you actually have to use a ruler. So here's a scale diagram of a salmon fry, which means baby salmon. The actual length of the salmon fry is 30 millimeters, okay, actual length. So that's the original. The original little salmon that's swimming around is 33 millimeters. Measure the length of the diagram, so that's going to be our scale, to determine to the nearest millimeter the scale factor. Or I'm sorry, so not to the nearest millimeter. We're just going to figure out the scale factor. Okay, so we have to take our ruler. Okay, and you have to know how to use this thing. And we're not going to use, we can't use an inches ruler, so if you have an old ruler at home, that sure is not going to work. Okay, and we're laying that down, and I worked that out to be 48 millimeters with my old lady eyes. Okay, so I said that that thing was 48 millimeters. So now let's just remember, because this is key to the success in the first 2 sections of this unit. You have to remember that to find scale factor, okay, just like so. So scale over the original. And I always write that down. Sometimes I just write S over O. So the scale was, we just measured it, 48 millimeters. And the original, it said in the little story here, was 30 millimeters. Now you can reduce the fraction, or you can simply divide and give it to me as a decimal. 48 divided by 30, and you should get 1 6/10. No unit. And you know that you messed up if you put the 30 over the 48, because you're going to get a scale factor that would be less than 1, and that would be a reduction. So it's important that we remember from yesterday's lesson that scale factor of an enlargement has to be a number greater than 1. If it's exactly 1, then that's just a duplicate, right? That's like making a Xerox copy of something. Okay, so that's question number 7. Now the next question that I wanted to go over with you is question number 12, and that's because the other thing that I told you was important was having the same units. So one frame of a film projector is about 55 millimeters high. The film is projected onto a giant screen, and the image of that film frame is 16 meters high. So we need to make sure that we have everything in the same unit. So you're either going to go everything millimeters or everything meters. It's entirely up to you. So let's just have a flashback. Well, that's the worst line I've ever drawn. Okay, meters is in the middle. We have decimeters, we have centimeters, and we have millimeters. Okay, so I'm going to put everything in meters. I just decided to do that today. So if I started off with my 50 millimeter size frame and I want to take it to meters, I need to move the decimal 1, 2, 3 places to the left. So I need to remember that in a whole number, the decimal is right here. 1, 2, 3. So my new measurement is the actual little film that goes inside the projector, which I don't think actually happens anymore. This is in olden days, is now 5/100ths of a meter. When we put it on the giant screen, okay, it turns out to be 16 meters high, which makes sense. If we think about being at the Cineplex, that's how big it is. This is the original. That's the one that's sitting inside the film projector. This is the scale up on the big screen. So how do we find the scale factor? Scale factor is equal to scale over original. So the scale is 16 meters. The original is 5/100ths of a meter. Line and a fraction means to divide. And we get that the scale factor is 320, which seems like a big number, but we have to think about it. It starts off really, really tiny, turns out onto the big screen. Okay, so that is the scale factor. And then the second question says, there's a penguin that's 35 millimeters high on the film. How high is the penguin on the screen? Okay, so we already know the scale factor, so we're going to take penguin here. Okay, and if he's on the little tiny screen, 35 millimeters, we're going to take that and we're going to multiply it by the scale factor 320. Okay, and he's going to be 11,200 millimeters, which is kind of an absurd number. So we could turn that, because this is good practice, back into meters. Okay, so then we're going to take this and we're going to we move from millimeters to meters, 1, 2, 3. So he is 11 2/10ths of a meter tall on the giant screen. Okay, so that was that assignment, and now I'm going to post another assignment for you to work on today that's working on this. It's not a race, okay? We got to make sure that we nail this down before we move on to reductions. Okay, take care.